Welcome to another mathematics lesson. My name is Kingsley Linus. In today's lesson, we'll be looking at the topic multiplication of numbers in base 2 under the theme basic operations. By the end of this lesson, you should be able to multiply binary numbers. It is important for you to note that before this lesson, you must have seen the lesson on addition of binary numbers. In the lesson where we learned about addition of numbers in base 2, we learned that number bases are like foundational blocks we use when we calculate, count, or measure things. Our focus in today's lesson is multiplication of numbers in base 2. Now recall that in the lesson titled Addition of Numbers in Base 2, I made mention of the fact that binary numbers or numbers in base 2 are very helpful and useful in the world of computing because it provides an easy way of storing information. But let's look at how we multiply these numbers in base 2. Multiplication of binary numbers is carried out using the rules of long multiplication as it is done in the decimal system. But to do this, we must pay attention to some basic facts. These basic facts are like guidelines that help in multiplying numbers in the base 2 system. First, when we have 0 multiplied by 0, it is equal to 0. That is in base 2. And 0 multiplied by 1 is also 0. 1 multiplied by 0 is also 0. Where we only have something is when we multiply 1 by 1. So 1 multiplied by 1 is 1, just like we have it in the decimal system. So we must pay attention to these rules whenever we do multiplication in the binary system. Now, here we have an activity. We are expected to multiply two binary numbers, 1, 0, 1 and 1, 1. Now, to do that, we will start by multiplying with the first one here. So 1 multiplied by 1 gives us 1. And 1 multiplied by 0 gives us 0. 1 multiplied by 1 gives us 1. Now we go on to the next digit. But before we do that, we have to write a 0 here to block this first position because we are moving to the next position of place value. Now, 1 multiplied by 1 gives us 1. 1 multiplied by 0 gives us 0. And 1 multiplied by 1 gives us 1. Now, it is easy to say that when we have 1 multiplying any set of number, we can as well just write out the number like we have here and here. Now, the next thing for us to do is to add up these numbers. We have 1 plus 0. It gives us 1. 0 plus 1 gives us 1. 1 plus 0 gives us 1. And then we have just 1 here, so we bring down 1. So this is our answer to this question. Now, in order to be sure that our answer is correct, we can do a check. If you convert the number 101 to decimal, you have 5. And when you convert 11 to decimal, you get 3. Now, 3 multiplied by 5 in decimal is 15. Now, let's look at the answer we've gotten. The first one here stands for 1. The second one stands for 2. The third one stands for 4. And the last one stands for 8. When we add all this together, 8 plus 4 plus 2 plus 1, you realize we'll have 15. So obviously, our answer is correct. Now, moving on to the second activity, we're expected to multiply the number 110 by 101. Now, we start from the first digit as usual. 1 multiplied by 0 gives us 0. 1 multiplied by 1 gives us 1, and 1 multiplied by 1 gives us another 1. Now, to the second line, we block the first position because we are moving to the next place value. Now, we have 0 multiplied by 0 gives us 0. 0 multiplied by 1 gives us 0. And 0 multiplied by 1 gives us 0. Now, to the third line, we have to block the first and the second positions because we are going to the third place value. Now we have 1 multiplied by 0, that gives us 0. 1 multiplied by 1 gives us 1, and 1 multiplied by 1 gives us 1. Now we add all we have together. 0 plus 0 plus 0 gives us 0. 1 plus 0 plus 0 gives us 1. 1 plus 0 plus 0 gives us 1. 0 plus 1 gives us 1. And 1, we bring down our 1 here. So this is our answer. We can do a check as well. If you check the number 110 base 2, if you convert it to decimal, you have 6. And when you convert 101 to decimal, you have 5. And 6 multiplied by 5 is 30. You can do a check. You realize that the answer we have here in binary is equivalent to 30 in decimal. This is how we prove our answer in binary multiplication. So we have some examples here. Example 1 says multiply 111 base 2 by 101 base 2. Now, we set out our numbers like we have here, and we begin to multiply. Now, for the first digit, 1 multiplied by 1, we have 1. 1 multiplied by 1, we have 1. And 1 multiplied by 1, we have 1. When 0 is multiplying, everything becomes 0. So we have 0, 0, 0 for the 3 places. And then the last one, multiply the 3 ones, gives us 1, 1, 1. Now we add what we have so far. Here we have just 1. So we bring down our 1. 1 plus 0, we have 1. 1 plus 0 plus 1. Our result is 1, 0 in base 2. So we write down 0, carry 1. So we bring the 1 here. So we have 1 plus 0 plus 1. That gives us 1, 0 in base 2. We write down 0 and carry the 1 again here. So 1 plus 1, that gives us 1, 0. We write down 0 and then we move the 1 to the next significant bit. But since there's no number, we drop down the 1. So this is our answer to this problem. Now moving on to the second example, we have the numbers 101 multiplied by 11. Now we start our multiplication. We take the first digit. 1 multiplied by 1 gives us 1. 1 multiplied by 0 gives us 0. 1 multiplied by 1 gives us 1. And then to the second digit 1. 1 multiplied by 1 gives us 1. And 1 multiplied by 0 gives us 0. 1 multiplied by 1 gives us 1. Now we add all we have here. 1 plus nothing, we have 1. 0 plus 1 gives us 1. 1 plus 0 gives us 1. And then 1, we bring down our 1. Now, notice that in these two calculations, I didn't bother putting in a 0 at these positions while I was solving, because I believe that you already have the understanding that when you are multiplying with the second digit, that is when you are moving to the second line, you skip the first position and move towards the left. And that is why we didn't bother putting in a 0 here and 2 zeros here, as well as 1 0 here. I hope that was clear enough. So with this process, this is how we go about our multiplication. Having seen these examples, let's try out some exercise. Now, at this point, you pause the video and try out the exercise yourself. I'm sure you are done. The answer to question 1 is 110, 111. And the answer to question 2 is 110010. Finally, the answer to question 3 is 11000111. So if these were your answers, you are correct. This is where we come to the end of this lesson. But before you go, let's look at all we've learned in a summary. First, we learned that number bases are like the foundation blocks we use daily when we count, measure, or calculate things. Secondly, we learned that apart from the decimal number system, there are other number systems, for example, the binary number system, and so on. Moving on, we learned that counting in a group of 2 is the same as counting in base 2. This system of counting has been found very useful in computing and its applications. Also, we learned that in the multiplication of binary numbers, we make use of the rules of long multiplication, just like the decimal system. Then we add our numbers using the rules of the binary number system. And lastly, we saw the rules of multiplication in the binary system. 0 multiplied by 0 gives us 0. And 0 multiplied by 1 gives us 0. 1 multiplied by 0 gives us 0. And 1 multiplied by 1 gives us 1. Having learnt this much in this lesson, let me find out how well you understood today's lesson with some questions. Try out these questions. Question 1 says, find the product of 110, 111 and 1101, all in base 2. The correct answer is option B. Question 2 says, find the product of 1001 and 1010, all in base 2. The correct answer is option A. I believe with all we've learned today, you won't find it stressful multiplying numbers in base 2. Till we meet again in another mathematics lesson. Bye.